Hello and good morning. Welcome to the second of our news conferences today, which will focus on the science and technology flying aboard the Artemis II mission. I'm Nilofer Ramji with NASA Communications. Here to talk with us today, we have Mark Clampin, Deputy Associate Administrator for NASA Science, Matt Ramsey, the Artemis II Mission Manager, Debbie Korth, the Deputy Program Manager for Orion, and last but certainly not least, Jacob Bleacher, NASA Chief Exploration Scientist. After some brief opening remarks from each of our speakers, we will take your questions. For those of you in the room, feel free to just raise your hand and we'll bring a mic over to you. And for those of you on the line, feel free to press *1 to get entered into our queue. So with that, we'll kick it off with Mark.
Thank you, Nilofer. So I'm really excited to be here today. Artemis is one of the most daring, technically challenging, collaborative programs ever undertaken. And science is a key part of that. And I'm speaking today on behalf of the Science Mission Directorate. NASA Science has always been a pathfinder for NASA exploration. And you can go back to the very first Explorer mission a year after Sputnik flew, which discovered the Van Allen belts. And in the time between that first flight and now, we've landed on the moon, landed robotic exploration on Mars. We've driven around Mars with a number of different rovers actually conducting experiments. We've even, in the last couple of weeks, announced that we may have found evidence of microbial life. We've flown on Mars with helicopters. And then we also worked with our colleagues in the Astronaut Corps to pioneer working in space on the SOHO mission, and then a lot of work on restoring Hubble Space Telescope. And just recently, we finally restored our ability to land on the moon with a successful landing by part of the CLIPS program. So we have a very large and invested role in bringing science into the Artemis program. This Artemis II mission will actually see 3 astronauts fly around the moon, and this provides a really great proving ground for doing some work that we believe is important as we, first of all, go to the moon, and then beyond that, go to Mars. So this will be the furthest and also the closest approach to the moon in about 50 years. And as you know, the goal is to stay and establish a sustained presence on the moon. So we think it's important that we establish a sort of playbook for what you might consider interplanetary travel. And we've been doing that in science for the last 25 years, working with astronaut colleagues on the International Space Station. And of course, as I just mentioned, we've also been setting robotic probes both to the moon. We've continued to monitor the moon with the Lunar Reconnaissance Orbiter for the last 20 years. And of course, we've sent loads of probes to Mars to really understand and do a know-as-you-go, we like to call it, to understand the nature of the planet Mars. On the Artemis II mission, we'll have 3 astronauts to do a lot of the science for us in different ways. And there are really 3 themes that we see in this mission as it pertains to science. The first one is the nature of deep space, and I'm going to talk a bit about that, and then I'm going to come back to it at the end. But one of the key elements we think of know before you go is really understanding what are the stresses in deep space. We've done a lot of work in low Earth orbit, but once you get outside the Van Allen belts, you're in a very different environment, which is, very hostile with a lot of high-energy cosmic rays, radiation, and also you're at the sort of mercy of coronal mass ejections, which fire lots of high-energy particles into space from the sun. So one of the things that we're doing on this mission is sending the astronauts with their avatars. And avatars are small USB-sized tissue chips. And on these chips, we can essentially, having drawn blood from each of our astronauts, put individual tissue that corresponds to different organs. And we can use these to monitor things like the health, monitor how they respond to the environment. And this will be very important for building both our understanding of the stresses, just doing the very first Artemis II, but later on as we go and establish sustained presence on the moon, and then hopefully go to Mars in the future, we can use these as a way of understanding what the impact on the astronauts is going to be. So it's a way maybe in the future that we can actually build health kits that help us ensure our astronauts are safe. Having 3 astronauts on the mission also means that we have eyes on the moon, and they will be able to probably see parts of the far side that were not seen during Apollo, so this gives us a lot of opportunity for additional geological work, and they'll be equipped with cameras and taking images that we can then use to basically follow up geologically and also potentially look for new landing sites. Finally, another important part for us is that this is going to be an integrated effort. So Artemis is fully integrated with science, and on this mission we will have science in the control room and an integrated part of the team. So Artemis 2 is really the first opportunity to test out that whole setup and make sure that we have everything right for the subsequent Artemis missions. So let me just return back to astronaut health. You heard Lakeisha talk earlier about space weather. Space weather is when the sun, when it's very active, ejects material, very high energy particles that can be a significant radiation hazard to astronomers. We found this initially with Apollo, getting outside the Van Allen belts for the very first time. And tomorrow we will be launching from Kennedy 3 missions: IMAP, the Space Weather Follow-On mission, and the Carruthers mission. And these are all providing different pieces of the picture for space weather, so that for the Artemis 2 mission and for subsequent exploration missions, we can provide very accurate forecasting and monitoring for the astronauts while they're actually conducting these missions and ensure that they're safe for the whole mission. So just to finish up, as a big picture overview, NASA science is really providing a foundation for human exploration, both initially for the moon with Artemis program, and then later on for Mars, where again we need to know before we go a lot of things in order to make sure that we can safely go there and return. So we really look forward to exploring the moon, Mars, and beyond. And I will hand over to Matt. Thank you.
Hey, thanks, Mark. Hey, it's great to be here today, and it's a pleasure being with you. All these bright and shining faces here. The panel this morning gave you a pretty good overview of what the mission looks like, from pre-launch to mission to post-launch. I'm going to talk a little bit about the principles that drove the design of that mission, and some of the mission objectives and some of the technology. So the principles that drove the design of the mission for Artemis 2 were quite a bit different than the ones that drove the design for Artemis 1. Artemis 1 was intended to be a shakedown of our machines that we're eventually will use to go to the moon and Mars. That was a fantastic mission, very successful. We were able to figure out how to operate the machines that are going to take us there. Artemis 2 is a little bit different. We're shaking down different things for Artemis 2. Looking forward to inclusion of the crew systems, and that's crew systems on the ground as well as in flight. So keep the crew safe, be able to retrieve the Orion spacecraft, because we do have reuse goals for Artemis 2 and beyond for the spacecraft components, and eventually reuse of the full crew module. So, and then the last thing is mission objectives. What do we want to accomplish? What did we want to accomplish in the design of this mission? And really, that's thinking forward to burning down risk for future missions, Artemis 3, 4, and beyond, where we will use this hardware to transfer the crew from Kennedy to the moon, and then from lunar orbit to the lunar surface and back. So priority number one of the mission objectives is to test out the crew systems in space. There are environmental control and life support that Debbie will talk a little bit more about. That is CO2 removal, waste removal, that sort of thing is very important. We did not fly this system on Artemis 1, so it will be a shakedown of that system. We'll also utilize some of the equipment on board for exercise. In the second lap that we do, the 24-hour HEO orbit that we'll do, that will break out the exercise equipment. All the astronauts will exercise, increase the metabolic rate, increase the CO2. They'll need to be cleaned from the system. So that is one of the starkest changes between Artemis 1 and Artemis 2 is that we'll do a 24-hour checkout for those crew systems. We want to demonstrate the systems and ops that are required to do follow-on missions. So all of those things like stowage and logistics and all of those things are very important. We obviously did not do that on Artemis 1. We'll be doing that for 2. I mentioned we'll want to retrieve the hardware. The intent is to download all of the data. If that does not occur during the mission, we'll obviously want to pull that, but we want the hardware. We want to be able to retrieve the secondary payloads on the Orion spacecraft that Jake will talk here in a bit. So those are very important objectives for us. We'll also do emergency and off-nominal training as we transit from and to and from the moon. So radiation shelters, medical procedures that we'll be able to do on the crew, and then fire response and suit donning and doffing, that sort of thing. And then finally, we have flight test objectives, remaining flight test objectives, if you will, that are very important to us. Suit operations, cabin pressure, cabin depress, those types of operational activities. But we do have two secondary payloads, our flight test objectives that we have. One is National Geographic. A couple years ago, Nat Geo offered to work with us on capturing all of the activities that the crew will be doing during this 10-day mission. That's very exciting for us. They'll be there for close approach and that sort of thing, but also kind of daily activities that the crew will be ongoing. And then we also have an optical comms system, laser comm, that we'll be using on the Orion spacecraft that will be able to do laser comm back with the Earth. That is a new technology that we're proving out. We also have, I think Lakeisha may have mentioned earlier, we have 4 secondary payloads that will be deployed off of the upper stage. She mentioned those, 3 of which are already on the Orion spacecraft adapter that's being translated over to the vehicle assembly building this week for mate. We have a 4th that's on schedule to be received this week and inserted prior to Orion delivery to the VAB. So I think that was pretty much it for me. Debbie, would you like to talk some Orion stuff?
Yeah, good afternoon. Glad you guys are able to join us today. I'm really excited to talk a little bit about the safe and reliable and really capable Orion spacecraft that will be going in this mission in just a few short months. So talking about Artemis 2 spacecraft, the Orion spacecraft is made up of about 3 main modules. We can put the animation, that'd be good. There's a crew module, service module, and the launch abort system. And so I'll start at the top with the launch abort system. So this is a system we hope we never have to use, but it's there in case we need to pull the crew module away from the rocket, either on the pad or during the ascent phase of flight. It's flown on Artemis 1, but it was an inert system. Since we didn't have crew, we would not be utilizing it. But it is designed to pull the crew module away. It can go 0 to 400 miles per hour in about 2 seconds. So very capable system, needs to outrun the SLS rocket in case there was an issue. But in a phenomenal mission, we'd be jettisoning that system at about 3 minutes or so into the launch. And I'll move down to the crew module, which is where the 4 crew members live and work. It's designed to allow crew members up to 21 days. Our mission, obviously, on Artemis 2 is 9.5, 10-day mission. In the crew module, if you look at the outside, those kind of shiny black tiles, the back shells, those are silica tiles. Those are very similar to what we flew on the space shuttle. The belly of the space shuttle uses similar tiles. And on the very bottom of the crew module is the heat shield. And those two systems are very similar to what we flew on Artemis 1. Once we get inside the crew module, though, there's a whole lot of differences that Matt alluded to. This will be our first flight of our environmental control and life support system. So you really need a metabolic load to test those systems out. You're looking at carbon dioxide removal, humidity removal, air vitalization, fan speeds, those kinds of things. And so without a crew there, it doesn't really buy you anything to fly those systems. So we'll be flying those for the first time on Artemis 2. The other new systems will be the displays and controls. So 3 displays that are provided to the pilot and the commander on this mission, mostly menu driven. There's about 60 manual switches, but the rest of it is very software and kind of a glass cockpit driven system to fly the spacecraft. As a part of the RPOD demo that Matt mentioned, we will be doing this fly around the ICPS once we undock from that in the HEO orbit, and the crew will actually be flying the spacecraft around that using those displays and controls, the rotational and translational hand controllers. Other new items mentioned are all really for the crew comfort and living space that they need. So a waste management system, basically a toilet. There's a whole hygiene bay that'll be flying in. An exercise device to keep the crew healthy. Any mission over, I think, 9 days requires exercise. So we're actually testing out this system on Artemis 2 to make sure that the environmental control and life support, the carbon dioxide removal and the humidity removal can keep up with exercising crew members in this small volume. Also flying a galley and a water dispenser system so the crew can, hydrate food and heat their food with a food warmer. So much nicer creature comforts than maybe some of the previous lunar exploration missions had. Also inside the crew module, there's radiation protection that's provided. So inherent to the structure, there's radiation protection, but we also actually can utilize the Oasis bays, which is where all the stowage is. They can use that to protect themselves during a radiation event. And finally, I think one of the newer systems as well is the crew launch and entry suits, the orange suits that they wear at launch and entry. One unique feature about the Orion crew suits is it does allow for a contingency return in case there was a depressurized cabin. So the crew can actually live in those suits for up to 144 hours. Has ability to provide them food and hydration, medication, and remove waste. So definitely a new system. Again, we hope we don't have to use that, but it is there for crew survival capabilities on their way back. And finally, if you look at the bottom part of the spacecraft, that's the service module. The majority of that module is provided by our European partners. It's a European service module. It provides all of the commodities required by the crew module and the crew during the mission. So all the power, the propulsion, water, nitrogen, oxygen, those are all stored in those areas. Heat rejection. Includes 4 solar arrays, which is unique, allows these longer missions rather than just fuel cells. So with the solar arrays, we can actually extend these missions up to 21 days. It contains the main engine that'll be doing our trans-lunar injection burn on this mission as well. So the OMS engine on that service module will be providing that TLI burn. As Matt mentioned, we'll be doing that after we check out the ECLSS system in that 24-hour orbit. So where are we today in fabricating and getting the spacecraft ready? The next picture is a picture of the Orion 2 spacecraft that was in our operations and checkout facility at the Kennedy Space Center. That was right before we handed over to the Exploration Ground Systems folks. This was in May of this year. So crew module and service module stacked together there. You can see, solar arrays and the spacecraft adapter at the bottom. So this is as we were getting ready to roll out that spacecraft to the next facility, which is the MPPF. So the MPPF is where those service module commodities all get loaded. So all of the fuel, the oxidizer, the water, the nitrogen, oxygen, all those things get loaded in the MPPF. And that was completed earlier this year. We also performed a crew equipment interface test in that facility. So the 4 Artemis 2 crew members were able to get in their suits and get into the actual module they'll be flying in and do a series of system checkouts and testing out the interfaces that they have with the equipment in the crew module. That was successfully completed, and we moved on from there to what's called the launch abort system facility, and that's where the launch abort system gets stacked on top. So you can see here we just finished finished stacking the motor tower as a part of that launch abort system. And there's 4 ogive panels that are put on to close that out, something north of 800 fasteners to put that thing together, nearing the end of that activity. And very soon, in early October, the integrated crew module, service module, and launch abort system will roll out of that facility and head towards the vertical assembly building to get stacked on top of the SLS rocket. So, next picture is really a picture from Artemis 1, but this is where we're headed. This is we'll be in this configuration, likely end of this year, early into January. I'm headed out to the pad. So I love this picture. I love that picture of the moon in the background, our destination. And, and our goal with all of this is to provide a safe, reliable, and very capable spacecraft that can carry the crews to the moon and bring them home safely again and enable the science that we're talking about here today. So with that, I'll hand it over to Jake. Thank you.
Thanks, Debbie. This really is an exciting time. We're preparing to send 3 United States astronauts and 1 Canadian astronaut around the moon. I mean, it doesn't get more exciting than that. And I just wanted to thank you all for being here with us to have this conversation and to help us tell the story about what we're about to undertake. As you've heard from my panel members here, that there are a number of objectives, test objectives with our test flight of Artemis 2. But you've also probably gotten the sense from us that we all agree our top priority is to bring our friends safely home at the end of this mission and to bring our spacecraft back. To do that, we have developed an integrated research campaign that will support all of our future Artemis missions to make sure that we can travel safely in space and bring everybody home. And that really starts with trying to understand the space environment. Mark talked a little bit about that at the beginning, and so I'll probably re-emphasize that a little bit. So we really want to understand that environment so that we can begin to spend more time away from the Earth, more time at the moon, around the moon, and eventually prepare ourselves to go to farther away destinations like Mars. Now, we're not starting from scratch on that. We do truly stand on the shoulders of giants. We've learned very much from the decades that we spent in low Earth orbit. But as Mark noted, the astronauts that spend time on the ISS are within the protective envelope around the Earth that helps shield us from some of that space weather in the deep space environment. We have learned much from the astronauts who traveled to the moon previously. But although we studied the moon, we studied our systems, we didn't necessarily study ourselves the way that we can today. So that puts us in a really good place for developing this integrated Artemis 2 research strategy to really focus on understanding that environment, how it impacts our astronauts, life in general, and the systems that we'll be flying in. I believe that when we leave home, one of the reasons we leave home is to learn more about ourselves. So in that sense, you could really say that the science of Artemis is the science of us. So we will be collecting some of the baseline data here of how humans operate when they get away from the Earth. It's what we need to have in mind if we want to spend more and more time farther away. I'd like to say that during exploration, science is our toolbox for survival. So with Artemis 2, we're taking the next steps for exploration into new places, steps for humanity to explore far beyond the Earth-Moon system. So with that in mind, I'll run through some of the payloads that we have underway. Our research plan includes a series of experiments and activities. And you heard Mark already mention AVATAR, a virtual astronaut tissue analog response. Again, this is a small experiment. But it could lead to really big impacts for healthcare, both for our astronauts, but also people here back on the Earth. It's about the size of a thumb drive, and it contains cells that we developed from blood draws that the astronauts provided to us before they left. So basically, we're making a stand-in for those astronauts, or an avatar. This study in particular will focus more on bone marrow, because bone marrow plays a vital role in our immune system. So basically, we can take this activity and we can simulate the astronaut being on board and learn from how those cells react. But also, in addition to what we can learn from the study itself, we will be testing out the study as it can be applied to future activities. So as we think through how we can start to fine-tune some of these studies for individual astronauts and think about preparing for the folks who will be spending more and more time up there, we can prepare them by sending up avatars in the similar way that we're talking about here. The next study will measure astronauts' well-being, activity, sleep patterns, and interactions during their time in this deep space environment. This activity, called ARCHER, which stands for Artemis Research for Crew Health and Readiness, involves our crew members wearing movement and sleep monitors or actigraphy devices, like this one I have on my wrist right here. They'll wear these during the mission, but they will also wear them before and after the mission as well. The wristband monitors enable us to study their real-time health and behavioral responses while they're in that environment. And as you heard from Matt, the crew will be conducting a number of activities that will kind of, one sense, generate them breathing more, generating more CO2, but it will run their bodies through a lot of different scenarios. And so as they do that, we'll be able to monitor how their body is responding. So we hope to gain a better understanding of how best to provide good sleep opportunities to the crew in their confined spaces, and how to just help them operate at the maximum level that we can going forward into future missions. Our next study includes the collection of saliva, basically your spit. Saliva is basically a window into how our immune system is functioning. So we call this activity our immune biomarkers. So during Artemis II, our astronauts will be able to supply saliva samples, and we can compare those with saliva samples collected back here on Earth as well. The crew provide those samples by blotting, basically licking these special papers that they'll store inside of a pocket-sized booklet. And then we'll store that saliva in a dry environment. When they return to Earth, we will then be able to rehydrate those saliva packets and conduct some analyses. So we can look for stress hormones, antimicrobial proteins, evidence of reactivated viruses, and much more. So this research provides insight into how a person's immune system will be affected during these deep space missions that we'll be flying in the future. Artemis II crew will also become the first astronauts in deep space to participate in our spaceflight standard measurements. NASA's been building a database of spaceflight standard measurements for some time in low Earth orbit. During Artemis II, though, we'll be adding the deep space travelers to this database. So it's something we hope to continue as we look forward into future missions. The spaceflight standard measures during Artemis II will include psychological assessments, measures of head, eye, and body movements during, before, and after the mission, as well as looking at blood that will be drawn before and after. These data help us assess their nutritional status, cardiovascular health, and again, focusing in on their immune system. Also, the crew will conduct activities to assess their balance, vestibular function, and muscle performance. So again, we can generate those activities, or we can watch as they go through many of the activities that Matt's already described. Once the crew then land back here on Earth, they'll participate in basically an obstacle course, followed shortly thereafter by a simulated EVA. One of the reasons we want to do that is really understand how the human responds to changes in gravity. And this is really important as we think forward as astronauts spend time traveling to the moon. How quickly can we expect them to operate and function once they land where they don't have a support network behind them? It's even more important when we think about traveling to farther away destinations like Mars, where they'll be in transit for many months before we expect them to operate on the surface. So this really is one of our first chances ever to start studying how the human responds to that gravity transition. We plan to take full advantage of that. We'll also have a suite of radiation sensors. Artemis I was well equipped with radiation sensors to help us characterize that deep space environment. That was very successful, and it helped us prepare for future explorers traveling through that environment. Well, that future is now. We're sending our friends through that environment, our Orion spacecraft again through that environment, and they will have that Orion outfitted with the sensors, as Debbie talked a little bit about. The astronauts will actually carry sensors in their suits that can help us understand how much each astronaut is exposed to, how much radiation. And then we'll have 2 sets of sensors, one that the crew will distribute throughout the Orion after they're up, that will help us understand what the general radiation environment is throughout the spacecraft. And then we'll also have a set of sensors that help us understand how well the shielding that Debbie talked about performs. So we can get a sense of if that radiation environment is constant throughout, or are there some of the locations as we're preparing to help protect them should there be an event that we need to seek shelter from. In addition to those activities that are integrated approach to understanding that environment and its impact on our astronauts and life in general, the mission will enable us the opportunity to observe the moon. So Mark talked about that in his opening comments. I just want to mention, depending on when we launch and what the trajectory is, the crew will be able to look at the moon through the window of the Orion. As it's been described earlier this morning, the moon will look about like holding a basketball at arm's reach. So they'll be able to see a good bit of the moon, if not all of it, from the position that they're in over several hours. As they do that, one of the great things about the human being and the human brain and the human eyes is it's basically the best science tool that we have. And so they will be able to probably describe things that no human has ever seen because none of the missions are identical. So they will see unique conditions that have never before been seen and be able to look out the window, observe what they're able to see, and then describe and document for that for us. So in addition to doing that, they will be helping us understand how science operations work as they describe and document for the teams back here on Earth. With a science evaluation room right here at the Johnson Space Center. So working together there, you can see that we have a campaign of doing the research, but also understanding how the research is done so we can understand operations in the future. So I just want to conclude again, sometimes it's hard, my face almost hurts from smiling at the excitement about this. This is really a fun time to be working in spaceflight. I hope that you're as excited as we all are about Artemis 2. Very proud about this opportunity coming up. I also hope you have a better understanding of our integrated research campaign and what it is that we're trying to learn by flying this mission. Again, I will just remind everyone our top priority is to bring our friends home safely, to bring the Orion home safely so that we can learn from the mission. And again, when we explore, the science that we carry with us is really that toolbox to enable that safe and successful mission. So these Artemis test flights that we're flying now and have already flown are the building blocks from which humanity will step out away from the Earth to explore the solar system. So I'll hand it back to you, Nilofer. Thank you.
Thanks, Jake. Definitely exciting. And thanks to each of our briefers for your remarks. We'll now open it up for questions. So if you have questions in the room, feel free to raise your hand. And for those of you on the line, feel free to dial *1 to get entered in our queue. If you find that your question has been answered, you can press *2 to withdraw it. And we'd like to ask you to whom you'd like to direct your question to and state your affiliation. And we also ask that you limit to one question to start. So why don't we open it up?
Nicole Mortellero from the Canadian Broadcasting Corporation. I don't know who I'm directing it to, but I'd like to know more about the exercise that will be conducted in such a small space. What does that look like?
I'll start and you guys can jump in. So the exercise device is called a flywheel, and it's actually mounted right when you walk inside the hatch of the crew module. It's right there on the floor. They can perform 2 types of exercise. One is rowing, and so they actually row into the empty volume of the crew module. So while the other 3 crew members are sort of staying out of the way, the one exercising crew member exercises out into that volume. There is no seat, so it's a rower, but it's not like a rower you'd have at the gym. There's no seat required. They're just rowing out into the free volume. They can also use it for resistive exercise device to help keep the muscles strong as well. So the rowing is the cardiovascular part, and then they use it for resistive. They can do squats, deadlifts, other things. So there's different attachments you attach to this flywheel, and it's very much the harder you pull, the more it wants to pull you back. So there's a little bit of training that's associated with it. So the crew members are actually participating in training here at the Johnson Space Center on that device over in the astronaut gym. So they're actually doing their workouts on that device so they can get used to it. So it is tight. That's part of what we're looking at on Artemis 2 is to see how does this work when you've got other crew members trying to do other activities while you have one person some of which are some very tall people on this mission, see how that works out. But that's one of the things we're testing out. We're also looking at how the dynamics of that device interact with the spacecraft, because they're putting load into the spacecraft. So are our reaction control system engines having to respond? How does our GNC system read these disturbances that are going into the spacecraft? So this mission is short enough that exercise isn't absolutely required, but it's going to be required for longer missions. So we need to know how does the exercise work, and then how does the spacecraft respond to this dynamic activity?
Yeah, I think just to add a little bit to that, the cruise is going to be asked to exercise daily. I think it's 30 minutes a day, so there's a 2-hour block for all 4 crew members to exercise.
Just one more thing, that exercise is part of a foundation that enables the research we're conducting with Avatar, Archer, some of the other activities I described, because it will help the astronauts go through a series of different stressor type events so that we can make the measurements I've described. So all of this works well together throughout the mission to provide us with the data we really need.
Perfect. Thank you for that. We have one more in the room.
Thank you very much for this. It's Ivan Semenik with the Globe and Mail. As we heard already, there have been a lot of robotic eyes on the lunar surface for many years, and this mission won't get that close to the lunar surface. On the other hand, you're going to have all these human eyes looking at the moon for the first time in more than half a century. So what I'm wondering is, what do researchers at NASA think, what surprises could the moon still hold for those human eyes, and how is the crew being trained or prepared to take advantage of that limited opportunity?
Well, I can start that if you'd like, Mark, and then you can conclude. This is one of the things about science, right? We don't know what we don't know about the destination, but we also have learned a tremendous amount from those observations you've described that do help generate questions that we have. So we have a series of questions that our Science Mission Directorate documents in what we call our decadal surveys that kind of direct the research we want to do. And then NASA carries a document called the Moon to Mars Objectives document that also highlights what we're trying to learn. But, the types of questions that we can ask ourselves that involve the moon, I always like to talk about, we have questions about humanity, about life in general, but the environment here on the Earth erases much of the evidence from the time period when life got a foothold. But the moon, our space companion, was there the whole time, and it still holds evidence about what was happening in the early solar system at those times. So when we use these missions, these test flights, to get us ready to get down onto the surface and land at the south polar region of the moon, we'll be able to start looking for evidence, collecting samples, making observations to answer big questions like that. But at the same time, your point about, well, what can we really see when we look out the window from Orion in this mission? Maybe this won't be that decadal level science that we can do, but very few people have looked at the moon from this angle. And this crew will have an opportunity to basically see the majority of that moon. So being able to look at the limbs of the moon, the edges of the moon as we're passing by, we're very interested to see what they'll pick up on, what they'll see. Are they seeing differences in, colors? Most people think that the moon is only, gray. But the human eye can pick out a tremendous amount of detail. So this is one of the things for this test flight is, what can we see? What can we learn? And really getting at how can we communicate that back to the Earth and describe what we're seeing and document that.
So I'm going to give a slightly tangential answer. I think Jake has talked about the moon, but I just remind you that the first time we did this with Apollo 8, one of the most inspiring sort of images of our time got taken, and that was a complete surprise. So Jake talked about the unknown unknowns. If you think back to the Earthrise image that was taken by Bill Anders, nobody was expecting that to happen or to have such an impact. So it's always the things you often don't think of or you're not expecting that end up having a big impact. And I'm not a lunar scientist. I actually come from astrophysics, and that particular picture is propagated through not just in one branch of science, but it's kind of propagated into how we think about the Earth, even how we think about planets around other stars. I mean, for a long time, we've been looking at that image, saying, how will we know if there's life on another planet? So it's always the unexpected that, presents that real scientific surprise.
Awesome. Thank you for that. We'll go on the side of the room over here.
Hi, Andrea Leinfelder of the Houston Chronicle. Mark, I want to make sure I understood you correctly. Could the Artemis 2 crew help pick a landing site for Artemis 3? And Debbie, Artemis 1 had Alexa on the Orion spacecraft. Is that being brought back for Artemis 2? Thank you.
I will let Jake speak as well, but I think the basic idea is that they will certainly be looking for future potential places of interest. And obviously, if there is sufficient interest, then one might want to land there in the future. Jake?
Yeah, for Artemis 3, our intention is to land in the south polar region of the moon, and then from there to start building up architecture and infrastructure so that we can have longer periods of time that we can stay at the moon. The information that these astronauts will collect when they are flying around the moon on Artemis 2 will certainly be accounted for in the decision-making process. So in that regard, I think everyone who's observed the moon is part of our decision-making process. But then we have a team that brings that data together and works through it. And it's, landing site selection is a balance between where you want to go and where you can safely get to. And that's what we have to work through. So I think in that regard, we're all a part of that process because we're all a part of collecting that data and understanding that environment.
Okay, and I'll address the Alexa question. For those that didn't know, on Artemis 1, we did fly a kind of a digital assistant on board, and it allowed people on the ground to interact in a more personal way with the spacecraft. We could ask it questions, where are you today? And Orion would answer where it was in the trajectory. It was a long mission, almost 26 days. You could say, play music, do party lights. I mean, it was a lot of fun and interesting way of engaging. We are not flying that system on Artemis 2 because we have the crew on board. So most of the personal interaction will be with the crew members getting their direct feedback on what they're seeing, experiencing, and working with the spacecraft. They are looking at ways to integrate digital assistants for the future, but the short answer is for Artemis 2, there will not be Alexa. We'll have the actual 4 living, breathing human beings. Yeah.
Thanks, Debbie. We will take one more in the room.
Thank you. Mark Carreau with Aviation Week and Space Technology. During your initial mission description, you brought up the radiation protection, and I'm wondering how you will be monitoring that. What would prompt you to ask the crew or tell them they need to go to the shelter, and then how would they be prepared, and how long could they be in there, and how effective do you think it is if they were in the path of a coronal mass ejection? Could they be okay in that shelter? Bottom line. Thank you.
I can take the onboard detectors. We do have onboard radiation detectors. Of course, that would be way after a CME, but Debbie, you can probably talk the radiation shield itself.
Yeah, the radiation shelter, it's actually just in the floor of the spacecraft. There's a bunch of stowage lockers, stowage areas, and so they would actually empty out the stowage, and all 4 can fit in there during the event. I'm not don't know all the specifics of the training they're doing along how long they could stay in there, but the intent would be they could stay until that radiation event had passed, and the protection is provided by the structure that's as a part of that floor and the backbone system.
Yeah, and I would just add to that the sensors that are on board the Orion, they're not an alert system to us. They are characterizing the environment that the Orion is actively flying through. The protection part of the studies are to understand how much protection we can provide in different ways within the Orion. So some of the sensors will be placed in locations so that we can characterize that. Were we put into one of those events, we would do the best we can to protect them, as Debbie noted. But I will add, and I'll kind of look to Mark on this one, is that the system that we would use to help us understand if something's coming, we would lean on our Science Mission Directorate partners who have spacecraft in flight right now that is very critical for us to understand the space weather environment. That's where any ability to predict something that's coming our way would come from. So this really is a full NASA integrated effort as we learn how to travel through space.
Yep. And I'll just add, our space weather team will use all of our heliophysics missions that are operated by the Science Mission Directorate and our partners at NOAA, the space weather missions that NOAA flies. I mean, primarily they're part of their weather satellites, but they are now starting to move to flying in individual space weather missions. And as I said, we're launching the first of those tomorrow, the space weather follow-on. So the combination of all of those missions allow us to really sort of do as much forecasting as we can. And part of the Science Mission Directorate's mandate in heliophysics is to improve our ability to not just tell you space weather is happening, but actually understand the physics of the sun, so we get much better at forecasting as well. And forecasting is going to be more and more important as you start to think about trips to Mars, for instance.
Thank you for that. We'll head over to the phone bridge really quickly. We do have Marcia Dunn with the Associated Press. Marcia?
Oh, yes. Hello. For Ms. Korth, I'd like some more details, please, on the galley and the toilet. Did any parts of the toilet or galley fly on Artemis 1 just to check out some systems? Are they similar to what's already on the International Space Station? And what's the backup plan if the toilet breaks, as it's sometimes prone to do in space? Is it a separate room with a door, a curtained-off area? Any details? Thank you.
Sure, yeah. So the toilet, first of all, is located in what we call the hygiene bay, so it is a separate door. So again, when you walk into the spacecraft through the hatch, it's actually underneath the floor there. There's actually a door that they can use to close. There's also a privacy curtain, so if there's more space needed, they can leave the door open and put up a privacy curtain. So it's very much similar to the design of the U.S. toilet that's flown on the International Space Station. We don't have the equipment that the station has to recycle water, so we're not doing that part of the design, but the actual mechanics of the toilet, how it functions, is very similar based on the ISS design. In terms of contingencies, in case it doesn't work as intended, we've had a lot of conversation about this, particularly about would we actually do the TLI burn or not, would we go to the moon. So we are actually flying contingency equipment, urine collection bags. They can still use the toilet for other functions, even without it functioning, to be able to dump the urine overboard. But there is actually contingency bags, collection devices that the crew could use and still be able to dump systems overboard. So right now the intent would be, if it doesn't work as planned, that's what they would go to as the contingency method. You mentioned about the galley. So the galley, we have a food warmer, again, very similar to what they fly on other missions. It's a kind of a suitcase-looking thing that's like a hot plate that lets you heat up your food. The galley is a water dispenser, so they actually use the water, again, very similar to previously flown systems, that you can refill dehydrated food and then actually use the food warmer to heat that up. So a lot of the systems that we try and fly flight crew equipment-wise are very much heritage, evolved some to fit within the size and mass constraints of Orion, but intend to use technologies from other spacecraft where possible. I don't remember the third. Was it about the flywheel?
Did any of these fly on one?
Oh, no, I'm sorry. None of these systems flew on Artemis 1. So we did not have the toilet installed. We didn't have the water dispenser, none of these items. So these are all first-time flight of these. This is why this 24-hour period is really critical, this checkout period in the high Earth orbit, to make sure all of these systems are functioning. We actually have exercise scheduled in that period so we can really wring out the entire ecosystem. But there are specific activities planned during that 24-hour checkout leading up to that TLI burn to say we're good to go and all of these systems are functioning the way we intended.
Thanks, Debbie. We're going to take one more on the line. Jeff Faust with Space News. Jeff?
Hi. Question probably for Jake Bleacher. When the astronauts are going by the moon and doing observations of it, are they going to be basically going through a checklist of looking at certain things based on what the science team on the ground wants to look like, or they're going to be open to looking at other things? And will they have anything more than the actual naked eye or perhaps a camera lens to observe the moon with? Thanks.
Yeah, thanks, Jeff. That's a really good question, and I love the opportunity to talk about it, so I appreciate the question. So the crew have actually gone through a good bit of geology and science training before this flight. So it's been great to start getting them wrapped into these activities, as well as being prepared for the other activities that they'll be doing. So they will have a checklist of sorts of things to look through and suggestions about what to look for, but they will also have, the whole reason we send people is for them to have the autonomy to do what they think is right based on the training that we've given them. So we like to say that, we have a phrase, we say, look odd. You have to look first, then you are observing what you see. So we want to get them to the window to look. We want to give them the chance to observe and then describe and document. And so they will have the Orion, just as before, will be equipped with cameras that can take pictures as well. So we will get plenty of image feedback to accompany what they're doing. And they will have cameras on the inside. And it will kind of be up to them how much they want to rely on that versus how much they want to look at the moon themselves. But the key is to make sure that they're communicating what they're seeing to us and helping us understand how that connection works with our ground crew here on Earth, who will be eagerly awaiting all the details that they're providing. So for this first flight, or this test flight on Artemis 2, again, we've trained them. They'll have a sense of what they need to step through or should step through, but then we will rely on them with that training and their autonomy to do what they think is best and really just communicate to us what they can see from Orion.
Great. Thanks, Jake. One more in the room.
Hello, Michael Burton from the University of Nebraska-Lincoln. Jacob, this question is for you. It sounds like you're collecting quite a bit of qualitative data from the astronauts and their experience viewing the moon. And as we start to think about Mars in the future, along this mission, are you getting some qualitative data on their emotions, on their feelings, and how that might affect their judgment going forward into deeper space beyond the moon?
Yeah, that's a great question, and I just want to point straight back to the fact that we have an integrated research campaign for this trip, because most of what I described is really trying to understand how the human being responds to being in this deep space environment. And I talked a lot about how these activities will help us understand their immune system. So there's the core of just a human being in general, but there's a good bit trying to understand, are they able to repeat the same types of activities at the same level? Is there any change in the way they're operating? How are they interacting with each other? And I think that gets to what you're asking, is really driving towards how they work as a team and maximizing their ability to do that, to get the jobs done that we're giving to them. Because that really helps us understand how to plan missions, how much time we have to work with. And so again, going through a lot of the activities that Debbie and Matt described, like exercising in a small space, right? Like, are we getting in each other's way? Can we find ways to do these jobs so that we can get through it? So you're right there's a lot of quantitative data, there's a lot of qualitative data, and we want to see them go through these different activities so we can really judge that. And then we'll compare with when they get back to Earth, how are they doing when they get back here as well?
Great. One more in the room. Micah.
Hey, Micah Maidenberg, Wall Street Journal. Maybe for Mark and Debbie, could you talk a little bit about scheduling the astronauts over, each 24-hour period after that, assuming the TLI, checks out and, you go out there. Are you scheduled down to the minute? What's the balance between work and rest? And if someone could provide a couple of examples of food that the crew will eat, that'd be great. Thanks.
Yeah, I can take the planning part of it. Yeah, so all four of the astronauts have all of their days fully loaded, meeting some of the objectives that I mentioned earlier. I don't know if it's down to the second. It's not down to the second, but it's it's very detailed. So I find it kind of funny. In fact, to further that, one of the comments earlier is that on flight day one, we get through most of the work, and then they take a 4-hour nap, and then they do the major burn, and they go back to sleep. I can't imagine going to sleep beforehand or going back to sleep after, but that's the kind of blocks that we're talking about that we're scheduling each of the crew for.
Yeah, and I'm going to add our friends in the Flight Ops Directorate. They're the ones that do all the scheduling, and so there will be a very detailed timeline day by day as as Matt mentioned, where, every activity, every flight test objective, every DFTO, every experiment, everything that needs to be done is fully planned out before they go. Now, that's not to say every day something may change, and so those timelines get reworked kind of, overnight while the crew's sleeping each day. So our mission operations directorate here, or flight ops director, are the ones that do that work at the detail level. In terms of food, there's a huge variety of menu that's provided by the food lab here at JSC, and so the crew members actually spend time going to that food lab and sampling the different foods available to them. Several of these crew members that are flying on Artemis II have flown on space stations, so they're very familiar with the food choices. So they're over there now picking out their menus, working with nutritionists to make sure that the foods they're picking out meet their nutritional needs. So I don't know anything that's not on the menu. You hear everything from pastas to shrimp to mac and cheese to hot sauce to tortillas to, it's a pretty extensive menu that they get to go customize for their needs.
Awesome, thank you. We'll take one more in the room.
Ken Chang, New York Times. This is for Mark. I was wondering, how good are space weather forecasts now? Can you forecast a week out that there's going to be a big sunspot pointed at Earth that might put out a CME?
I think we're getting better, and we've been able to start to get a handle on, the big storms like the Gannon. But a really solid forecast, I think, is still something that we're striving for. And obviously, the missions that we're putting up now will give us much better insight into not just the one piece of the problem, but the whole problem, from what's happening on the sun to how that then propagates out from the sun and whether it becomes a real problem or not. So we have a lot more to do, I would say.
And Matt, or Mark, if I could add to that.
Sure.
Just there's being able to predict that it will happen, but what's really valuable to us is knowing when it does happen, because it's not instantaneous that the radiation levels change at the Orion. So having the warning that it has occurred, whatever the event is, has occurred, gives us time on board to talk to the astronauts and prepare themselves for it. And, as we already mentioned, we have, possible options for them to try and shield, and any protection is better than no protection.
Yeah.
Great. We do have time for one more question. We'll take one from the line. We have Manuel Mazzanti with Exploración Especial. Manuel?
Thank you so much. Manuel Mazzanti from Exploración Espacial. I would like to know a little bit more about the optical communication systems that you're going to use. In the previous call, they mentioned that as Orion gets farther away from Earth, we are going to be switching to the deep space network with limited bandwidth. So my question is, we all know how important are HD videos and good photography for public engagement. So what do you need in order to have like a live feed using the optical, this O2O communication system? Do we need a relay satellites, or what is it? What do we need to have a live feed of good bandwidth?
I can take that. Yeah, so the components of the optical comm, there's a transmitter receiver on the Orion spacecraft. There are ground stations at Table Mountain, California, and White Sands, and potentially a site in Australia. So there will be certain times of the day that we will be able to communicate with that optical comm system back to Earth. That we potentially have the real-time option, but it's not the baseline communication system for the spacecraft. That's the DSN and the near space network for TDRS and that sort of thing. So that's the primary, and we also have a secondary S-band comm, and then the optical comm is a flight test objective, basically.
Great, thank you for that. Unfortunately, we are out of time to take our questions. So thanks to all of you who raised your hand, who submitted questions, and thanks to our briefers today who took the time to talk to us a little bit about the science and tech that's flying on the Artemis 2 mission. We hope that you'll continue to follow along tomorrow. We do have a crew news conference that is scheduled for tomorrow at 9 a.m. Central with the Artemis 2 crew members. We'll also hope that you follow along with the mission by visiting nasa.gov/Artemis. Thanks again for joining us.